Uh, Greetings, everyone. So, I am Vashisht on behalf of my teammates Rupali, Syed, and Vipulesh. So, a lot of my friends have talked about a mission on Mars, but how to reach Mars and what should be the parameters in order to reach Mars? These types of questions will be answered in this PPT. So, let us start with the introduction. So, basically, for understanding these parameters, we need to have some prerequisites. So let us start with the Julian days. Julian days is the continuous count of the days since the beginning of the Julian period and is used primarily by astronomers and in software for easily calculating last days between two events. For example, GMAT and STK use Julian days and Julian dates. Julian centuries is basically the same type as the Julian days. State vectors are nothing but the position and velocity vectors of a certain body moving in space. Now we go on to the Keplerian elements. Basically, the first Keplerian elements is epoch. Epoch is nothing but the date and time of the certain body in space. Orbital inclination is the inclination between the equatorial plane of the body and the orbit. And right ascension of the ascending node is short formed as a RAN. It is nothing but in space we have Earth is spinning continuously. This means we can't use a common latitude and longitude. For this, we have created uh, an astronomical coordinate system known as RAM. It is basically the angle measured in the equatorial plane from the vernal equinox, where the right ascension is zero. Next on, we go on to the argument of perigee, short formed as AOP. It is basically the angle between the ascending node and the periapsis of the orbit. Next up, we have eccentricity. Eccentricity is define the shape of an orbit. True anomaly is basically the angle made by the celestial body with the periapsis. And semi-major axis is nothing but the distance of the body from the like the sun. Now we move on to the algorithm for calculating the orbital parameters. So first up, we calculate the orbital parameters by calculating the Julian day number GD using this formula, and then we calculate the T naught. It is T naught basically is the number of centuries between the Julian year 2000 and the date mentioned in the problem. Using this formula, we calculate the T naught. And we calculate the orbital parameters of any celestial body using this formula. Orbital parameters like semi-major axis, centricity, inclination, and all the other parameters we calculate using this formula. And then the semi-major axis is calculated, and then the angular momentum at the Julian day is calculated using this formula. Then after that, the argument of perihelion and mean anomaly M at Julian day is calculated from the following formula. After that, we use Kepler's equation, which is M is equal to E minus E sine E for calculating the eccentric anomaly, that is the capital E. And after that, we calculate the true anomaly theta of any celestial body using this equation. After we have calculated the true anomaly, we calculated state vectors of any planet like Earth or Mars using these steps. After we have calculated the state vectors, we use Lambert's algorithm for calculating the velocity at departure. Let's say we have to take a spacecraft from Earth to Mars. So we need to calculate the velocity of departure and arrival of the spacecraft. So Lambert's problem is helpful in finding that. Then after that, we have got the after Lambert's problem, we have got the R1 and R2. From that, we calculate the transfer orbital elements. So I have made a Python code. So in order to calculate all the steps, so here is the Python code for calculating the orbital elements. It is basically a 200-line code. So I will quickly, so I have already run it in order to save time. And here is the result. So we input the epoch values. For example, I have taken in reference to the Mars Global Surveyor mission, which was launched in year 1996 and on 7th November 1996. And it reached Mars in 12th September 1997. So using this data, we calculate the transfer elements of the spacecraft in order to reach Mars, which are here. These are the transfer elements we need to get in order to reach Mars. And this is all the calculation which I shown in the PPT. And here is the final result. So thank you.